everyone. Uh, I'm Abhinav. Today I'll be conducting this session. I'll be talking about uh, uh, how to estimate your throughput requirements, and we'll be talking a bit about request units and why are they essential. So I do not know how much deep we have to go on request units, so I'll start basic and then gradually move on to more advanced topic, but would try to skip a lot of basic stuff. So in between, if you have question, feel free to just ask a question or just raise your hand, and Shweta or someone else from the team will note and will take up the questions, or you can also put the questions in the chat. As I present, I'll not be able to look at the chat, so Shweta would probably be looking at the questions and we'll be taking it during our pauses. So yeah, let's get started. Uh, this is how today's session will be lined up. We'll be first talking about what happens when we execute requests behind the scenes, what happens in Cosmos DB, then why at all we need something like request units, then how request units are used as a currency to pay Cosmos bills, then what is the relationship between RUs and throughput, and how do you actually estimate why you need to estimate throughput, where do you actually have to use it, then what are the factors that affect required throughput, and then at the end we'll cover the most important part, how to actually estimate throughput, because estimating throughput properly would basically go a long way in reducing your costs on Cosmos DB. So uh, that's how we'll be covering the topics for today. So just a quick overview. Whenever we are performing any operation on a computer system, there are three most essential things. One is compute requirements, the other is memory, and the third is IOPS. Compute, you know that if we are processing anything, we need some computation power. And if we need to process something, we also need to hold it in memory. So RAM, that's the memory part of it. And then how many such operations we can perform, that is governed by the disk speed, and that is IOPS. So behind the scenes in Cosmos DB also, because ultimately any database operation happens on servers, so these things come into picture. But if we expose these things to the end user, it becomes very complicated to figure out like how much charge for what thing, how much compute is required, how much memory needs to be allocated, and everything. So in Cosmos DB, we abstract out everything, and instead of talking in terms of different components, we talk in terms of how many are used, what capacity you need. So uh, uh, going back to this thing, when we mention RUs, why at all RU is required? So suppose you were to perform an operation in Cosmos DB and you incur certain charges. Why can't we just say that, okay, 1 KB write is these many dollars, and let's say one query will always cost these many dollars. Why can't we say that? So there are a lot of factors which actually decide the cost of these operations. One very simple naive example is if you look at point reads. So if you were to perform a 1 KB point read per second for an hour, you will be charged in Australian dollars $0.0107. In USD, it will be 0.008. In INR, it will be 0.6079. So if I give you three different exchange rates, there will be no correlation that you can see into that. So it becomes necessary for us to abstract these numbers as well. Also, the value of one USD will not always be one USD. So a lot of factors will determine that cost, and the cost may fluctuate. So we cannot say that if something is costing one USD today, it will cost one USD tomorrow. So it may go up or go down. So that will become extremely confusing for the end user. So that's where we come up with a virtual currency, let's say. and we call it request units. So think of request unit is like uh, how many currency coins you would require to perform a particular request. So the base is if you were to perform a 1 KB point read, you will always incur 1 RU. So for a single 1 KB point read, you will always spend 1 RU, irrespective of what other factors are. Even if compute increases, something goes down, geography changes, whatever, you will always incur 1 RU for a 1 KB point read. So that's where RU comes into picture. Request unit is basically the currency that we deal in. You always know how many request units you are consuming, and then accordingly, there will be that will be reflected in your bills. So at this point of time, I want to ask you if everyone is familiar with the concept of point reads and how many RUs are required for one point read. So let's conduct a quick quiz here. If I ask you to perform 500 point reads per second, so we have to perform 500 point reads in a single second on a 1 KB item. We want to know how many RUs you will need for that 1 second. So 500 point reads in 1 second on a 1 KB item. How many RUs will be required for that? If you think 60 RUs will be required for that 1 second, then just give us a like. If you think 3000 RUs will be required, then a heart. If you think just one RU will be required, just laugh away. And if you think 500 RUs will be required to perform 500 point reads in 1 second on a 1 KB item, then just act surprised. So we'll pause for a few seconds and see the answers. Just put your answers in the chat.
I think we got a couple of surprised reactions.
Okay.
Um, okay, there are more coming. Okay. I think it's safe to say that majority thinks surprise.
Oh, that's a relief. So I guess most of the people understand the concept of how many RUs we consume on point reads, and you also understand that how many RUs you'll need for every second if you were performing those many requests in a single second. So that's good. I can now move on to the next section. I wanted to cover this quickly because this was all like basic stuff and uh, not so much related to the main goal of this session, where we actually want to estimate throughput. So the next thing is how are RUs and throughput related? So in your quiz, you have already done this. Our question was if we were to perform 500 point reads in a single second. So I could have asked you if you had to perform 500 point reads, how many RUs you will require. So that answer would have been simple that you require 500 RUs. But the moment I say that you are performing those point reads per second, it becomes the rate at which you are performing those point reads. So throughput is nothing but the rate at which you are performing requests and the rate at which RUs are consumed. So uh, throughput helps you determine how many requests you'll be processing, and accordingly, you will allocate resources at your database or collection level. So uh, this you have already done in the quiz. So if you were to take an example again, if you have a workload where you are performing 100 point reads or 100 queries per second. So how many RUs you need to allocate for every second? That is the throughput. Now the question comes, okay, RU and throughput, this and that. Why do we actually need to know what throughput is? So throughput basically determines how many requests per second you can process. And accordingly, you have to provision this throughput when you are creating a new container or a database. So at that point, it becomes very helpful if you already know how much throughput you're gonna require according to your workload. If you are starting with a new application, let's say, and you know that 100 users will be coming per second and they'll be performing some operations and you'll require some bandwidth for that. So how much bandwidth you'll actually require for that in terms of database requests. So it's important to assess that. And if you head over to our Azure portal, uh, when we create a new database, let me show it quickly. When we create a new database container inside a database, let's say we are creating a new container, and yeah, so we just see this option. If you were to create a new database, it will ask you whether you want to allocate auto scale or manual throughput. These are just the settings that we make our in other sessions, but here you see this field. What is the max RU per second that you want to allocate for this database? So this is nothing but actually the throughput that they are asking about, and we need to know this before we can actually create a container. So that's why throughput estimation becomes very important. Also, when you are allocating, so let's say that you estimate that in your application there will be 100 users that will be hitting your application per second, and you allocate your resources accordingly. But then when you release your application, you see that no, not 100, there are 200 users that are coming, or let's say 120 users that are coming, and your application is actually not able to cater to all the users because it does not have those resources. So that's when the concept of throughput comes into the picture. You have to allocate throughput accordingly so that you can support all your users. Uh, so getting back to the slides, uh, do we have any questions until this point? What are RUs? What is throughput? Why throughput estimation is required? And where do we actually need it? Do we have any questions regarding that? Shweta, do we have anything in the chat?
No, nothing in the chat. I think we are good.
Cool. So yeah, let's move on to the next section. What are the factors affecting throughput requirement? So we are building an application and we want to estimate our throughput, like to serve the potential customers, how much throughput we want to allocate. Then what are the basic factors that might affect how much throughput we need to allocate? So there are a lot of choices, and in the next section, we'll go over them and see how all of them affect our throughput allocation. But just to quickly look at them, uh, the combination of these factors will basically affect how much uh, throughput we want to allocate. The choice of API, whether it's a SQL, MongoDB API, or Cassandra workload, or Gremlin, or table API. How many number of regions we are deploying our workload in. So obviously, if we are supporting high availability by deploying our workload in multiple locations, so the costs will increase and the required throughput will also go up. So multi-region writes, if we are enabling multi-region writes, so again, we'll have to allocate a little more throughput for that. Then indexing policy, consistency level, how variable is our traffic, how big are the items that we are gonna store in our databases, and how many number of properties these items have, and what's our query patterns. So all these combination of all these factors will basically determine our throughput requirement, and tweaking one or the other, it may increase or decrease the number of RUs required for processing our workload. So uh, now we know that, okay, we need to allocate certain number of RUs to cater to our use case, and what are the factors that will actually affect this throughput. Then how do we estimate our throughput requirement? So we'll be covering three cases of throughput estimation. The first one is when you are creating a new application, a new workload. Then how do you estimate your cost so that when you create your database and containers, you know how much you throughput you need to allocate at the first place. Then the second case will be if you are coming from MongoDB, Atlas, IAS, or some other database deployment, on-prem deployment, where you know how many vCores you are using in your current deployment. So if you were to migrate to Cosmos DB, how much throughput you need to allocate. So that's the second case of migration. And then the third case is basically tracking your consumed RU. So as you deploy your workloads and you start catering to your customers, then your systems will also evolve. So you need to track how many RUs you are consuming in particular request, read, write request, and everything, so that accordingly you can estimate better in future. So how do you actually keep track of RUs consumed in each database operation? So that's the third scenario that we'll be covering. So talking about the first scenario, how do you actually estimate throughput for new workloads? So we have a tool, capacity planner tool, where you can actually tweak all these factors and see how much RUs you need to allocate for your workloads. So we'll take a dummy scenario where we'll choose SQL API and indexing policy. We have three indexing options: custom, automatic, or raw. So we'll choose automatic indexing, and we'll choose the default consistency, that's session level consistency. And then we'll like in our hypothetical example, we'll consider deploying it in two regions, and we'll also enable multi-region writes. Then we'll talk about variable traffic. Um, just to set base for this, when we talk about variable traffic, uh, I'll put two scenarios forward. One is uh, an IoT company who has put sensors in, let's say, some factory temperature sensors, and they are emitting temperature data every 5 seconds. So every 5 seconds they are emitting data. So during the day, and there are thousands of such sensors, but every 5 seconds, all these sensors are emitting data. So if you look at their workload, the amount of data that they are emitting every second is huge, but still this data is constant. So if they have 1,000 sensors, so every 5 seconds there will be 1,000 data points only. It's not like that. First, there will be 1,000, and then there will be 2,000, and then there will be 500. So it's a fairly constant workload. And let's say there is another use case where during the day, let's say for 1 hour, you have for the first hour of the day, you have 1,000 requests. And during the next 11 hours, you have just say 100 requests per hour. So in this scenario, the traffic is actually variable traffic, because during the first hour, you see that it's obviously much more than for as compared to the average traffic during the day. So it becomes an important point, and we'll consider this later. So I just wanted to uh, give two examples relating to variable and constant traffics. And then as we go through the capacity planner demo. We'll make use of these three items, and when we come to this, I'll explain what these items are. So let's head over to the capacity planner and see how we can make use of capacity planner to estimate our throughputs for new workloads. So yeah, so our capacity planner have two versions. One is signed in, and another one is signed out. So it is advisable that you use the signed in version of the capacity calculator. So I'll just sign in into this. Okay. Yeah. Yeah. So here it is, the capacity calculator. So currently what you are looking at is the signed out version. So the normal version of capacity calculator. This is the basic version. It is recommended that you use the signed in version of the capacity calculator. So I'll just sign in into my account. Wait for it to load. Yeah. So you can see that whatever settings we talked about in the previous slides, all these are a field in this capacity calculator. So let's get started with estimating our new workload. In the example, we saw that will be choosing SQL API. Here we can see there are three options: SQL, Cosmos, and Cassandra. So let's choose SQL API. And one other thing that I want you to notice is the moment we make any changes, uh, there is a banner which asks you to calculate the cost again. There is also a button at the bottom using which you can calculate. So it's just one thing that uh, you need to take care of. The costs are not automatically updated. You need to hit calculate again. So in our example, we chose SQL API, and we want to deploy it to two regions. So we'll increase the region to two. And then we also want to enable multi-region writes so that the data is written to more than two regions simultaneously. So we enable multi-region writes. And then we have a choice to choose the default consistency level. By default, the session consistency is chosen, but we have actually five options here: strong, bounded staleness, session, consistent prefix, and eventual consistency. If we enable multi-region writes, we do not get to enable strong consistency. If we disable it, we will have that option. So yeah, but in our case, we are enabling multi-region writes. So let's stick to the session. Yeah. Is there a question? Is there any question?
I think Eric may have accidentally unmuted himself or
Oh,
something.
okay.
Eric, do you have a question? Okay, I think, yeah,
Yeah,
yes, unmuted himself. Okay. Yeah, we can go ahead.
Yeah,
There's a question in the chat, but yeah, we can take that once you finish explaining. Yeah.
yeah, cool. So we choose the consistency level, and then the next setting is what indexing policy we want. So indexing, as you know, indexing helps in like better queries. So we need to decide what properties we actually want to index. So suppose we have an item that we are storing in database, let's say a teacher item, and the teacher would have a name, a phone number, uh, an identity number, something like that. So which all properties out of these we want to index? So that's totally up to us. We can index nothing and choose indexing policy off. We can index everything and choose automatic, or we can specify a custom indexing policy. So there are rules how you specify this that can be shared separately, but you can specify what uh, fields you want to index, if not all of them. So for this example, I'm choosing automatic indexing. Then the tool asks you how much data you want to store in your transactional store. Transactional store is basically your normal store that you would have normally come across. And we also have analytical store. But for this example, we don't need to worry about both of them. We can put any amount of data that we want. The next important setting is steady and variable. This is probably the most important setting. If you make a wrong choice here and later put on how many reads or writes you want to perform, it might give you wrong estimates, either very low or very high estimates. So it becomes very important to pay attention to what kind of workloads you are going to have. So again, talking about my example of IoT workload, there might be cases where are like workloads where you are getting a lot of requests every second. But if those requests are uniformly distributed over a period of time, and it's not skewed during a particular event interval, then we have a steady workload. If the requests are skewed, like there is a spike during a particular interval, then that is a variable workload. So we need to make a important assessment at this point of time, whether we'll be having steady workload or variable workload. And I want you to look at this section here when we have chosen steady workload. So now if I shift to variable, you see that we get two more controls. One is what for what percent of time we have peak. And then if you look here, we have two fields now for each operation. How many operations we perform at peak and how many operations we perform off peak. So this becomes very important. If you say that you have steady workload, but actually you have a variable workload where you, let's say during the first hour of the day you get 1,000 requests, and during the subsequent hours you get just 100 requests, and you put in your max number of requests here, 1,000. So it will be a gross overestimation, because now when we calculate RU requirement, we will feel that for all the 12 hours you require these 1,000 RUs. So we will suggest that you will require 12,000 RUs. But actually, you would only require 1,000 RUs for the first hours and 1,100 RUs for the next 11 hours. So it would be around just 2,100 RUs. So just a hypothetical example, not the correct numbers, but I just want to point out how you can overestimate those numbers if you don't decide properly whether your workloads are steady or variable. So for our example, let's say that we have a variable workload. Now, how do we determine for what percent of time we have a peak? So in my example, I said that for the first hour you have uh, 1,000 requests coming in, and for the next 11 hours you have just 100 requests coming in per hour. So if you take up a window of 12 hours, during the first hour, you have peak. So 1 out of 12 hours, you have a peak. So 1 divided by 12 into 100, 8% is the time during which you are at peak. So around 10 is fair estimation here. The next thing is, if you have a look at this, it says sample item 1 and add new item. What are these? What is the sample item that we want to put values to? So I'll just go back to my presentation and take up the example that we were considering. Uh, I have put up three different kind of items. So if it's a school system, we have teachers, classes, and students. Think of items as different tables. So like entries in different tables. So if you were to design a admission, let's say roster system for a school, so you'll be talking about teachers, you'll be talking about classes, you'll also be talking about students, and this data would be stored separately. So what is the size of one record for teacher, one record for student, one record for class entry? It will vary, right? And also, depending on what application you are making, how many requests you do on teacher table compared to how many requests you do on students compared to how many requests you do on classes, it will also vary. So items are nothing but different types of entities that we would store in our databases. So depending on how much each item is used, uh, the cost will vary. So let's head over to capacity planner once again. And in our example, we have three items. So let's say first sample item is the teacher item, and we can specify the size. So we have taken the example size as 1 KB. So let's put 1 KB. Number of properties. So number of properties is if we are storing teacher's name, teacher's date of birth, teacher's phone number. So these will be three different properties. So number of properties, it has an impact on cost when you are indexing everything. So if you have, let's say, 1,000 properties and you have to index all of them, so it will increase write cost. So let's say we have three properties for teachers, and we can come up with any number here. It doesn't really matter for our example. I just want to show you how to estimate our use. So let's just specify one item and hit calculate, uh, and see where do we get to see the required throughput that we need to allocate. So if you look at the costs here under transactional workload, it says estimated throughput at peak and estimated throughput off peak. So it tells you that we require 400 RUs at peak and 400 RUs off peak, right? So, so it tells you that on your database you need to allocate 400 RUs minimum, and 400 is also the minimum throughput that we can provision on Cosmos DB. So right now we are in minimum tier. Let's say we add another item. Let's say we have a student who's 1 KB only, but 30 properties. And if we are performing more queries on this, there can be different types of operations. It could be a point read and creates, updates, deletes, and queries, whatever. So depending on that, the number of RUs consumed will be different. And now again, let's hit calculate. So just make a note of these numbers, 400 RUs and 400 RUs off and on peak. Then again, we click calculate, and let's look at these requirements now. Estimated throughput at peak is now 100 and 1,194 RUs per second, and off peak we require 1,004 RUs per second. So this way we can tweak with these settings, and according to our requirement, whatever settings we need, we can put those settings, and we could specify uh, whether we have a steady workload or a variable workload, and what are the types of items that we have, and what uh, operations we are going to perform, and at what rate. So once we have done this, we would have a good idea about our systems and how many resources we have to allocate, and we can see from here how much throughput we need to allocate for our database. Where will this throughput be used? Again, going back to Data Explorer, when we are provisioning new container, creating new database, here we need to specify. So At the minimum, we'll have to specify 1200 RUs because we have 194 RUs per second and max of both of these numbers. So 1200 RUs at the minimum, we'll have to specify. We can go beyond that, but it might be an overestimation. So this is how we estimate the throughput requirement for new workload, and this is how we specify the throughput in the database. Uh, do we have any questions until this point regarding how we use the capacity calculator or how we estimated throughput? Anything?
So, yeah, there was a question in the chat earlier from Bill. It said, from my understanding, given the API flavor, MongoDB, SQL, or Cassandra, is above the common storage mechanism for a given underlying chunk of data. I guess one could end up with actual different RSU values depending on the high level API flavor. Um, I don't understand which storage mechanism you're referring to, Bill.
Well, is it
Yeah, but
related to transactional store or analytical store that you are saying?
yeah. So the RU charge does vary based upon the API version. Yes, that is correct. There might be some difference because the way we implement the APIs internally and the way the queries are executed for each of the APIs could be slightly different. So yeah, like Abhinav said, it's a combination of the CPU, memory, and IOPS, right? So that compute part may differ sometimes. So that's the reason why we might see a difference.
Yeah,
Abhinav, something you
but
wanted to add?
yeah, but if you are asking just about storage cost, I think that remains fairly similar, even if we change the API. So let's see. Yeah. So the cost per GB per month, it remains the same, irrespective of the choice of your API. So storage cost doesn't play is not variable here. It just depends on how many GBs of data you are storing. But actual variability will come in your workloads because the number of requests that your application has to cater to number of users, that will vary. And the other factors have a direct impact. If you have like if you tweak around with number of regions or whether you enable or disable multi-region rights, so that has a direct impact on each and every read and write operation. But storage is fairly fixed, so the cost is determined. For every GB per month, you'll have to pay $0.25. Yeah. Does that answer your question, Bill, or did you intend to ask something else?
Yep, he has mentioned in the chat that uh, his question is answered.
Cool. So, do we have any other doubts or any other questions that uh, I should address before we move on to the next section?
I think there's some more feedback from Damir. So he has mentioned that the calculator is a great thing, no question. However, dealing with approximately 20 variables make all this very, very, very complex, especially because some of the parameters depend on the behavior of the application, which is very often not predictable. I
Yeah.
think
So,
you're the right person to
yeah.
take that feedback, Abhinav. Yeah.
Yeah. So in that case, this calculator is basically just to give you a rough estimate. We do show you estimated monthly cost as well, but it's not recommended that you stick by those details. It just gives you a starting point. So if I were to ask you to put a number here in max RUs that you want to allocate, and you were to do it vaguely, then a user will be confused like whether I put 1,000 or 2,000 or 4,000, or they might think, okay, even 5,000 would be less. My application is so huge and there will be so many users. So we need to have a starting point at least. Obviously, when you deploy your application in production, you can change these numbers, the provision throughput numbers, you can change that according to the request. If you are getting more requests per second, then obviously you'll have to increase the allocated throughput. Otherwise, your request will be throttled because we would not have enough resources to cater to those. And if you are consuming less resources, then you can obviously like decrease the allocated throughput. So it's just a starting point. Obviously, if you are starting with your application and you think, why do I need more than one regions? So it's safe to just stick with one region. If you are not sure you need multi-region rights, so you can just disable it. In most of the cases, if you are just starting something, you might not need to enable these settings. But let's say if you are just, you are very well aware of all the requirements that you have. You know from day one that you are making a Facebook and you need to have a multi-region deployment, multi-region rights and all that. Then obviously these settings uh, come into picture. Otherwise, you can ignore a lot of them. Yeah. So
And yeah, I think just to add to that, Abhinav, I know that you have been putting in some effort into improving the experience in the calculator as well. But yeah, that's absolutely a good feedback from Damir. That maybe we should think a bit more about. And
yeah.
yeah.
Yeah. So, Damir, the absolutely critical thing to worry about here is whether you are estimating your workload correctly, whether it's a steady workload or variable workload. Why I recommend the signed in version of capacity calculator. If you go to the non-signed in version, then you get yeah. So you get fewer fields. It becomes easier, but then you do not have this variable workload option, and then in that case it might lead to overestimation. So here you do not have an option to choose variable workloads. So in this case you might just end up overestimating your requirements. So this is a simplified version, but it's not recommended because it might lead to overestimation of your costs. So that's why I recommend using the signed in version.
Thank you for this. I was not aware of this difference because I'm always working signed in, but but
Yeah.
why did you split that, if I may ask?
Uh, yeah, so for the same reason, so many fields become overwhelming. So we still wanted users to get an idea, but then uh, that may not be a good idea to encourage users to use the non-signed in version because it has a few critical controls missing, and that leads to overestimation of costs. And you might get an impression that Cosmos DB is extremely costly where it actually is not.
Yeah, okay, this makes sense. Yeah.
Yeah. Cool. So, do we have any other questions, Shweta, in chat or anyone else? Any doubts?
Not in the chat. Yeah, maybe if
Yeah.
people want to ask on the call, yeah.
Yeah. Let's move to the next scenario in interest of time. I think we have 13 more minutes, so let's try to finish quickly. Uh, I'll cover the next scenario now. Uh, we saw how we can estimate throughput for new workloads. Now, if you are migrating from some existing system, so let's say you have deployed your systems on-prem and you are managing the servers, the disk, compute, everything, and maybe there might be another scenario where you might be using services like Mongo Atlas, where you have provisioned clusters on some cloud provider M30, M50, M60, like that, or you might be using some IaaS services. In those scenarios, if you want to migrate to Cosmos DB, then how many RUs you will require, or how many RUs you will be consuming for that workload when you migrate to Cosmos DB. So that predictability helps you in planning your budget. So how do you deal with that scenario if you have to migrate from some other service to Cosmos DB? In such scenario, it becomes very important that you are aware of vCores or number of vCPUs that you are using currently. And in all those three scenarios that I mentioned, whether you are you have deployed your systems on-prem, if you are managing your CPUs yourself, then definitely you'll have an idea about how much compute required, how many vCores are in use currently. And if you are on MongoDB, Atlas, or something like that, depending on what cluster you are using, whether it's an M30, it has 4 vCores. If it's a M60, it would have, I guess, 20 or something like that. But it's quite predictable. If you are aware of your what you have deployed, you will know how many vCores or vCPUs you are using. Just have to each DBA will be aware of this detail. So how do these vCores translate into uh, RUs in Cosmos DB? We'll have a look at this. So two things we need to know: how many vCores person is using currently, and what is the replication factor, whether they are managing one replica or three replicas or four replicas. By default, Cosmos DB has four replicas, one primary and three secondary. So in Mongo, I think you can choose how many replicas you have. So there are just two factors that we need to be aware of: how many vCores are in use, and what's the replication factor currently. So uh, if we quickly look at this, there is an empirical formula. Uh, the number of required RUs uh, in Cosmos DB for a migration workload will be T divided by R into a constant C. So the value of C for SQL and Mongo API. So if you were to migrate from some other system to Cosmos DB and you choose SQL API, so what is the value of C? And if you choose MongoDB API, then what is the value of C? So in case of SQL, it is 600. In case of Mongo, it is 1000. So this is the formula that we can use to get a rough estimate of required RUs on Cosmos DB. C into T divided by R. What is T? T is basically the total number of vehicles that are in use currently, and R is the replication factor. So we just need to know two variables, and we'll be good to estimate the throughput requirement in Cosmos DB. So let's consider an example here. So we have an example where we have a replica set containing three replicas, and in each server we have four vCores. So if we look at our formula, what do we need to assess? How many total number of vCores we are using, and what is the replication factor, right? So we see that in our example, how can we get that? So if we look at the total number of vCores, the first replica has four, the second has four, and the third has four. So in all, we are using 12 vCores in this deployment. And how many replicas we have? We have three replicas in this replica set: replica 1, replica 2, and replica 3. So it's a fairly straightforward estimation. The value of R is 3 and the value of T is 12. And if this is a MongoDB API that we'll be using in Cosmos, so we'll use 1000 for Mongo into 12 divided by 3, and this gives us a number 4000 RUs per second. That's the throughput that we will require to migrate this given workload to Cosmos DB if we use Mongo API. Do we have any questions regarding this at this point? Does this make sense? Does this not make sense? Shweta, do we see anything in the chat?
Nothing in the chat.
Okay. So, so then let me move to the next section. This example was a straightforward example where we just had one replica set to deal with. and it's easy to see that there were 3 replicas and 12 vcores. Now let's say the real deployments may not be so straightforward. There might be multiple replica sets, and in each replica set, there might be different number of replicas. So how do we deal with that? How do we actually calculate uh, the value of R and T to put in our formula? So in this example, we'll consider a case of heterogeneous replica sets. So in this case, let's see, we have 3 different replica sets, and in each of them there is a different number of replicas that we have. So in the first replica set we have 3 replicas, in the second replica set we have one, and in the third replica set we have 5 replicas. So then what would be the value of R that we can use? If you look at the number of T is basically total number of cores. So total number of V cores that we have is straightforward. So in the first replica set, we have 4 into 3, 12 V cores. In the second replica set, we have 4 V cores. In the third replica set, we have 4 into 5 equal to 20 V cores. So if we add them up, we have in all 36 V cores that the person is using currently. So T value is fairly straightforward, but we need to see how we calculate R. So what is the replication factor that we need to use here? So to calculate that, we will sum up all the replicas, the number of all the replicas. From the first set, we have 3 replicas. From the second set, we have 1 replica. And the third set, we have 5 replicas. And we'll see across how many replica sets they are divided. So we have total of 5 plus 1 plus 3, that is 9 replicas divided over 3 replica sets. So per replica set, our replication factor is average replication factor is 3. So 3 is the value that we use in this formula this time. If there was one more with, let's say, uh, 3 more replicas, so that would have been 3 plus 1 plus 5 plus 3 divided by 4. Again, it would have been 3 only. But yeah, this is how we calculate the average number of replicas per node per replica set and use that value in the formula. So again, C Mongo into total number of vCores divided by the replication factor. And there is a typo here. I missed 10. So it will be 1000 into 36 divided by 12, and it will give us 12,000 RUs per second. So to migrate such a deployment to Cosmos DB, if we use Mongo API, we will require to provision 12,000 RUs per second as the throughput. Uh, do we have any questions related to this at this point? Shweta, do we see
Nope.
anything?
No questions in the chat.
Okay, cool. I should actually have put up a question myself. Cool. Yeah. So those were the two cases where we estimated, we found out how can we estimate new workloads. And the second scenario, if we were to migrate from an existing deployment to Cosmos DB, how do we estimate the throughput requirement? Then the third case is when you are already using Cosmos DB, how do you measure your RU consumption? For two reasons. One, how can you optimize your RU consumption by optimizing your queries? The other is as your traffic increases, how do you know that how much a particular kind of query costs so that you can increase your throughput requirement accordingly in advance? So it becomes very important to keep a track of how many RUs you are consuming whenever you are executing a particular operation on Cosmos DB collections. Uh, so how do we do that? There are multiple ways. There are actually 3 ways to track this. Uh, Let me show you quickly. The first way is through Data Explorer. So be it SQL API or Mongo shell, there is a shell access that you have. and you can execute queries in that. So yeah. So at collection level, you can execute queries. You see that we have an option of using executing a SQL query in Data Explorer itself. So let's do this. Uh, let's first have a look at what kind of items we have stored in this custom collection. So we see these items, pick just one of them and see. So when I was specifying number of properties, so these are the keys in the key value pair. So unit price is one property, total price is the one property, quantity is one property, type is another property. So let's look at all those items where the quantity is, let's say 4. So if we were to run this query where we have to identify all the items where the quantity is 4, so select star from C, where C dot quantity, right? Quantity equal to 4. So if I execute this query, it will return all those items which have quantity equal to 4. Just have a look at few of these records. So quantity is 4 here and quantity is 4 here. Now the important thing is looking at the query stats. How many RUs did you consume while executing this query? So you consume actually 8.66 RUs for this query. So you know that if you were to execute this query on these many items, if you had, let's say, 100 items right now, so it will require these many RUs for the same setting. So you have a rough idea how much your query, one query will require. And now if you have to execute 100 such queries per second, so you will require 8.66 into 100 RUs per second. So it will give you a rough estimate of how many RUs you need to allocate if you have just this kind of query in the same settings in the background. So this is one way to track how many RUs you are incurring in your query. The another way to do this is through the logs in our monitoring blade. So focus on these two, diagnostic settings and logs. So you need to enable diagnostic settings to be able to use this logs feature. So we go and we add a new diagnostic settings. It's same as like I'll just edit my existing one. So you get the same fields. And there are certain categories that you need to enable depending on your requirement. So let's say we need to find out data about query stats. So we have to have this thing enabled. So there are certain few categories that we need to enable, and where do we want to send it. So we send it to a log analytics workspace. So that's a separate topic, how to set it up. It's really straightforward, like allocating any other resource in Cosmos DB. But yeah, we send it to log analytics and done. Once we do this, we will have access to the data related to queries and all that in the logs. So we go to logs and uh, there are some predefined queries and you can write your own and save them. And let's have a look at the top 10 queries and the top 10 most expensive queries right now. So I'll run this query here and it will take a moment and it will list down all these queries that I have executed on my database. And the top 10s are, we are querying the top 10. So it will tell you what was the query text and how many are request units were consumed for that query. So you can actually have a look at what are the most expensive ones, what's the average size of your RUs consumed with your queries. So this is the second way of uh, keeping a track of how many RUs you are consuming. The third way is monitoring your RU consumption through our SDKs. So if you are building an application, most probably you'll be integrating one of our SDKs, Java, Node.js, or Python, or .NET, something like that. So you'll be integrating those SDKs and you'll be sending requests to the database through those requests. So whenever you are sending such requests. So here is an example. Uh, Here is a request to read item with a particular ID. So whenever we do this request, we get a response from the server. So as part of that response, we have a method, get request charge, from where we can actually see how many are you were consumed for that particular request. And if you see, we have logged it. So for this request, we consumed 1 RU. So like this, you can keep a track of all your requests. You can log these numbers and see if how many request units you are consuming for each request. So these were the 3 ways. So if you have any questions, we can pause here. That's all I wanted to cover in this section. Yeah.